10 amazing animals that farm. Humankind is not the only species to have had the idea of farming. Animals have been engaging in this practice long before us. Various species have formed symbiotic relationships to ensure a steady supply of food. Here is a list of 10 animals that could be considered farmers. Though these partnerships are mutually beneficial, one side is ultimately eating the other. Number 10. Leafcutter ants. Ants of the Antini tribe, including the Siphomermex longuscapus and Siphomermex muellieri species, depend on the fungi they breed. There are more than 78 species of ants that grow mushrooms. As these leafcutter ants move across the forest floor with large leaves on their heads, they create a colorful and fascinating picture. However, these ants don't eat the leaves, they chop them up and take them home. Instead, these leaves are used to nourish their mushroom gardens. Once the fungus has exhausted the nutrients it can get from the leaves, the ant removes the waste from the litter pile. Ants also secrete antibacterial agents that protect the fungus. The colony's largest food source, the fungi crop, is of utmost importance and is used to establish a new colony when a future queen takes a piece of the crop with her. This is because the climate of the ants' farms is not suitable for wild fungi growth, so they rely on a monoculture of their own crop, which is kept free of parasitic fungi through the use of bacteria. Number 9. Herder ants. Some species of ants not only cultivate crops to feed their colonies, but also tend to the equivalent of livestock. For example, Crematogaster scutellaris ants will take charge of aphid colonies and milk the honeydew they produce. This sugary liquid is created by aphids when they feed on plant sap and can be extracted by the ants through a gentle stroking of the insect's sides. Ants don't just feed on aphid colonies that they encounter, they actively manage them. Through their footprints, the ants emit chemicals that help to keep the aphids calm, making it less likely for them to wander away from the herd. In addition, ants have been observed to physically bite off the aphids' wings to keep them in place. Furthermore, some species of ants even bring aphid eggs into their nests to protect them from the cold temperatures during winter. Number 8. Termites. Farming has been around for a much longer time period than humans may have thought. Fossils have revealed that 25 million years ago, termites were already practicing a type of agriculture known as fungus farming. This method works in a similar way to leafcutter ants, where the termites transport pre-chewed plant material, such as leaves and wood, to their nests. These materials are then used as a growth medium for fungal spores to bloom into mushrooms. This discovery has put the farming timeline of humans to shame, showing that termites have been farming for much longer than 10,000 years. By cultivating fungus inside their nests, termites are able to thrive in drier climates due to having a steady supply of food sheltered within the mound. The fungus helps the termites to gain more nutrition from the vegetation around them by breaking down the cellulose and lignin, indigestible to the termites, into a nutrient-rich compost. Both the mushrooms and the compost are eaten by the termites, thus providing them with two sources of sustenance. Number 7. Ambrosia beetles. Members of the weevil family, ambrosia beetles, are found in many parts of the world and are known for their unique diet of fungus. This fungus, referred to as ambrosia or food of the gods, is harvested and stored in tunnels they bore into the wood of trees. The adults in a colony are responsible for tending to their fungus garden, cropping it to promote more growth. To move their fungus to a new tree, the beetles have a special organ, mycangia, to carry the fungus with them. Thus, these weevils are able to sustain their own food source as they travel. Number 6. Littorina snails. The Littorina snail may seem like an unlikely hero, but its risky behavior has a purpose: to create a nutrient-rich feast. By gnawing away at blades of swamp grass, these snails create a safe, fertile environment in which they can flourish. Once the grass is removed, the remaining soil is softer and more hospitable, allowing the snails to easily access the fungus they need to survive. This activity may be dangerous, but it's a small price to pay for the next meal. The Littorina snails are able to utilize damaged swamp grass covered in snail waste fertilizer for their own benefit, the perfect environment for fungi to grow. This form of farming requires minimal effort from the snails, yet yields a high nutritional value from the fungi. As such, the snails are able to maximize their food source with minimal effort. Number 5. The owl limpet. The North American limpet, known for growing up to 4 inches, 10 centimeters, in size, is the largest of its kind. These small mollusks are fiercely territorial, and use ramming to ward off intruders from their gardens. They cultivate a mat of algae with a size of around 1 square foot, 1,000 square centimeters, with the secretion of a mucus, which they use to graze upon. As they leave a slimy trail on their path, it helps to create an optimal environment for the growth of algae. Staying close to home also helps them to retrace their mucus trails, thereby providing a plentiful source of food. It takes approximately 3 weeks for a female owl limpet to create a farm in a barren environment. Once established, the farm can sustain itself for up to 4 years relying on staggered feeding and mucus secretion. However, if the limpet is removed, the farm will be devoured by other algae feeders within 2 weeks, devastating the surrounding ecosystem. In contrast, males of the species are opportunistic feeders who will raid nearby farms until they are chased away. Number 4. Damselfish. Longfin damselfish are remarkable farmers, cultivating algae in their territories and having domesticated shrimp assist with fertilization. As their digestive systems can only process certain types of algae, they establish territories to allow their preferred crop to flourish by weeding out unwanted species of algae. This is especially crucial as the particular algae that damselfish prefer are only found inside their farms, and outside of the fish's influence, other species of algae could easily overtake and outcompete it. Damselfish protect their farms by quickly chasing away any intruders, except for mysid shrimp. These shrimp form swarms on the farm, which is beneficial for the growth of algae. Additionally, their waste deposits enrich the algae, leading to higher quality growth. Researchers have conducted studies to compare the quality of algae on farms with and without swarms of mysid shrimp, and the results showed that farms with swarms had better quality algae. Number 3. Upside-down jellyfish. The Cassiopeia jellyfish is widely recognized for its unusual behavior of lying upside down. This positioning is integral for the jellyfish to grow and cultivate its inner supply of algae, zooxanthellae. With the underside of the jellyfish exposed to the sun, this allows for the algae to photosynthesize and provide the necessary nutrition to the spotted jellyfish. Although the majority of the jellyfish's diet is derived from its algae farm, it also uses its tentacles to catch food, such as zooplankton, which it stuns with stinging cells and then directs into its mouth. Number 2. Yeti crabs. It then digests the bacteria with its digestive juices, providing a vital source of nutrition in the hostile environment of the deep ocean. At the bottom of the sea, researchers have discovered a unique species of crab that boasts hairy arms reminiscent of the abominable snowman. These distinctive features have a purpose, though. The Yeti crab cultivates bacteria on its claws which it can feed on. Unlike other deep-sea creatures, such as shrimp, who rely on bacteria that already exist in the water, the Yeti crabs use their hairy arms to wave over fluid from hydrothermal vents or methane vents, nurturing the bacteria by supplying them with oxygen and methane. The crab is then able to harvest the bacteria by using specialized hairs around its mouth to scrape its claws, digesting the bacteria with digestive juices for vital nutrition in the dark depths of the ocean. Number 1. Pocket gophers. Examining the list so far, it was believed that humans were the only mammal to engage in farming. However, today's final entry has proven this to be untrue. Pocket gophers, small burrowing rodents, have been found to farm roots in their tunnels for up to 60% of their diet. This process requires a lot of energy, but the gophers have managed to ensure a steady food source by carefully tending to and fertilizing their crops. Although the gophers are not planting the crops they consume, their behavior still contributes to the propagation and growth of these food sources. The tunnels also provide protection from predators. As the gophers burrow further, they create safe pathways to explore. Down in the pocket gopher tunnels, the air is moist and the soil is full of nutrients from the gopher's waste. This creates the perfect conditions for roots of nearby vegetation to grow and flourish. The gophers then crop these new intrusions, which helps them to expand even more. Additionally, their tunnels provide safety from predators, allowing the gophers to explore deep into the ground without fear.